Now there is one last interesting feature which I also want to introduce, and that would be private constructors. Now what's a private constructor and which use does it have? There is a pattern in object-oriented programming which is called the singleton pattern. The singleton pattern is about ensuring that you always only have exactly one instance of a certain class. This can be useful in scenarios where you somehow can't use static methods or properties, or you don't want to, but at the same time you want to make sure that you can't create multiple objects based on a class, but that you always have exactly one object based on a class. Let's say for our accounting department, we want to make sure that we can only create exactly one object based on this class because we have exactly one accounting department in our entire company. We might have more than one IT department, but we have exactly one accounting department. Now, to enforce this and to avoid that we manually call new accounting department multiple times, we can turn the constructor of the accounting department class into a private constructor by adding the private keyword in front of it. Now what this does is it ensures that we can't call new on this. Here you see I'm getting an error because the constructor is private. So it's only accessible from inside the class, which sounds strange because how do we get inside of the class if we can't create objects based on it anymore? The answer is, well, static methods. A static method can be called on the class itself, so you don't have to instantiate it for that. So here we can add a static method, which we could call getInstance. That name is totally up to you though. Now getInstance will check if we already have an instance of this class, and if not, return a new one. For that we can add a new static property, instance, a static private property, so you can put private in front of static, called instance, which will be of type accounting department. So in there we'll store an accounting department instance. So that's what I'm saying here. I have a static property which is accessible on the class itself, but only from inside the class, and the value we store in there will be of type accounting department, so of the class itself. Now we can use this instance property here in getInstance and check if this instance is set. Here inside of static, if we use this, it will refer to the class itself, and then we can access all other static properties on that. The alternative to that would be to use the class name. And now if this is set, I want to return this instance, or again, class name.instance, but this inside of a static method works. It gives us access to the class itself then, unlike this in a non-static method, which gives us access to the instance with which we're trying to work, not what we're doing here. If, however, we don't make it in here, then we have no instance yet. Then I set this instance, so this static instance property, equal to new accounting department. We can use that from inside here, because now we're inside of this class method. So here we can access the private constructor and pass in our ID and our reports array, and then return this instance here. So now we're either returning the one instance we might already have, or if we don't have it yet, we create a new one. But this code, the marked code here, can only run once, because once we have an instance, we make it into this if block, and we return the existing instance. So now if we want to work with the accounting department, instead of creating it like this, we would call const accounting department.getInstance, and this returns us a new instance of the accounting department. But if I do this again, I will get the same instance, as you will see if I console log accounting and accounting2 here. You will see that the two should be exactly equal. If we save that and reload, you see down there are my two accounting department objects. They have the same ID, the exact same setup. They are the same object, the same instance, because we only have one instance with this singleton pattern, which is created with the help of the private keyword in front of the constructor. Now, this is arguably an approach which you won't use all the time. The singleton pattern can sometimes be useful. You don't need it all the time, but it's definitely worth to know about it because it is something interesting which you can easily implement with TypeScript thanks to private constructors.